Today we're going to be talking about the project flow within PVCAD Mega. The first thing I've done is gone ahead and gotten PVCAD installed into my my AutoCAD. You can see that I have my PVCAD dialog open and the PVCAD tab up here available. If we don't see this dialog, go ahead and click Show Dialog, and that should open this up. I've also opened up a template available on the PV Complete website. This has a title block for us with some linked variables and a plan set up for us in tabs. And the first thing I'm going to start to do is start to name my project. You can see over on the right on the first tab, the project number, name, address, and other details are listed for us. We can go ahead and enter those in, or we could load the properties in from another template available on the PV Complete website. You can see once I've entered those into Excel and uploaded them, those will pull into my project tab here as well. That's going to go ahead and go over to my linked variables in the template. If you have your own title block, you're able to also take these linked variables and move them around for your title block as well. But once we have this set up, we can go ahead and pop over to the model space, which is where we'll do most of our work. You can see a compass is already set here for us. The first thing I want to do when I'm here is run the units command just by typing units right into anywhere. I click enter, and we'll see I'm going to be designing in inches today. You can go ahead and change that to whatever you like, but it's really important we set this before we do anything with importing of maps or things like that, so we make sure everything's to scale. So once I'm set with that, I'll go ahead and set my location here. I have two options. I have map and file. If I click map, it's going to bring up the built-in geolocation services within AutoCAD. I can put in street address, latitude, longitude, landmark, and we'll go ahead and give me this preview that I can move around and I can get imagery from this method. Alternatively, and what we'll do today is I'll click set my location and go to file, and I'll pull in a KMZ file that I have available. This KMZ file has imagery already associated with it and some boundaries already defined. So you can see I got a boundary, I have a road here, I have some buildings, I have a stream, and a little pond and some other buildings. So I've gone ahead and gotten these all already lined out for us. One thing I can do is I can go ahead and hide the visibility of the imagery. So this isn't deleting, it's just toggling the actual visibility of it. And very quickly, just because I know there's a lot of different experience levels of CAD users out here, you'll notice I clicked to select this. I clicked to the right of it with a left click, and then I dragged to the left, and you can see as soon as I encounter an object going from right to left, it will go ahead and highlight that object. If I were to go ahead and left click on the left and go to the right, you can see I'm encountering that object, but it's not highlighting it. So when I go, the difference is when I'm going from left to right, I need to encapsulate the entire object. You can see I'm grabbing this road object here now. As soon as I get all of it within my selection pane, going from left to right, if I were to go right to left, as soon as I hit it, I'm able to select it. And then once I have something selected, I'm just pressing the escape key to deselect it. So very handy to be able to grab things in different ways. And with that, I'll go ahead and start to define my site by going to the Site Objects tab up here. I'll select my outline, ground mount outline. You'll see I have a unitless entry here. I'll remember I'm in inches. So I'll go ahead and define that setback here. You can see that this has defined that setback and drawn it in. If I go ahead and click that and go to the Home tab, I can see that it's actually defined it as an AutoCAD layer. If I needed to, I could go ahead and change the names of those layers by going to Settings, Layers, and I can define those however I need. Now I can go ahead and grab my obstructions here with that left select. I'll just call these obstructions. I'll give it a uniform setback of just 24 inches. I'll define all those at once, and I'll click Escape, and you can see that those are defined now. I can also use any of my AutoCAD commands here. I'm going to use rectangle. I could also have done that with from home just up here. But I'll go ahead and draw in one of these buildings just to show you what an obstruction with some height looks like. If I go ahead and define that, you can see it's going to go ahead and cast a shadow object. So this shadow object here is stayed within the boundaries of my obstruction already, but if this was towards an edge, it could potentially have gone out. So it's good to check on that. The shadow is calculated based on solar position and time interval as well. So if we need to alter those, we can go ahead and do that in settings as well. Once we're comfortable with our site and we have it built up how we want, we can go over to our mechanical layout tab where we're going to go ahead and insert our design parameters. So here you can see we have user defined, we have next tracker and array technologies available to us as well for trackers. We also have fixed end trackers available. I'm going to go ahead and just use user defined single axes. In this case, we're going to go ahead and define our structure down here. But first we'll also define our modules. So this is a database that's updated every time you open up PVCAD. It is talking to our servers in the cloud here. We keep our panel library pretty up to date. So if there's something you don't see in here that you need, let us know and we'll get it in here. If you're stuck and you need it right away, you can use this database button to import a pan file or create it manually as well. Just if you give this file to a colleague or something like this, that's not going to be available to them, so they may have to do some redefining here. So we do suggest you bring it up to us. There's also the info button here that's going to give us a spec sheet. Everything's formatted the same for every panel, so which is kind of nice. You don't have to search around for it on various spec sheets. Then we come to the layout tab. This will really depend on how you want to lay your property out. Here I'll say a 0.3 GCR. You can see when I click away, it's going to go ahead and calculate my row spacing and pitch based on that. These are all related. Another thing to note here is the structure length. I have 3, 2, 1. So this is saying I'm allowing structure lengths of 3, 2, and 1 of the base structure design that I'm going to create down below. So this being user defined, I can go ahead and define my row quantity, column gap, loader gap, all of this. And if you hover over any of these, it will give you a cheat sheet here of what exactly that quantity is. On your screen, that should look a little bit bigger. I apologize, that's a little small here on the preview. And then if you need to get more in depth about pier distances or where those motors are placed, you can open up your pier distances tab as well. And once we have this all defined, we're at a point where we can go ahead and make a layout. So if I click Make Layout and I drag over here, it's going to ask me for the layout relative to north. So I'm going to go ahead and put in 180 degrees. And you can see I have this single tracker now floating around. As long as I click within my property here, it's going to go ahead and place it everywhere possible. So here you can see it made my maximum design for me. I can come over to the summary tab and I can see how big that is. I can recalculate my energy. And that will give me an estimated energy production. You can see my gears turning here. And here's an estimated production, not a shading report, but a quick web call that will give me a rule of thumb here. If I go ahead and come and delete some of these trackers, I just click the delete key and you can see that updates instantaneously here. If I wanted to add trackers in, I can't copy and paste them, but I can, if I wanted to kind of replace the trackers I just stole, I can click add tracker and then select the panel I want to continue that row back with. And I can pull those back in as needed. If I wanted to click and drag, I can select how many trackers I want. So I'll select 3 here, 180 degrees again, and it gives me an option of default and reference. The default is going to be squared off just like they are here. I can just drag them in. Or if I wanted to give it a reference, I can give it a reference to design again. So if I wanted to design against this slight bend here. I'll make it a little bit more obvious, but you can see that here I'm designing, keeping that 180-degree azimuth of the panels. I'm giving it that edge to go ahead and design along. So I can go ahead and edit things as needed there. Alternatively, if I wanted to go ahead and do a maximum capacity, so say that I only had interconnection for 10 megawatts, I can go ahead and add that constraint in here. I can go ahead and make the layout. Let's try that again. And I give it a central position here. So here I'm saying the center of my 10 megawatts, I want to be here. And it will go ahead and make sure that everything is as close as possible to that center point, while adhering to my limitation. So you can see it comes in just under that 10 megawatts. Alternatively, we have some other tools available to us. The first one is the access roads and equipment pads. So if we want to kind of have a grid style layout where we have some roads and we have some equipment pads already defined for us, we can go ahead and use this. What we do is we set up a single block, and it replicates that with some spacing between it. So a nice way to look at this is click the info button and we can get a visual. So there's two options we have: the maximum capacity fill, and then there's going to be a full block. So here is that standard block. So for us, we're defining it as a 32 by 2. This is saying it's going to place as many of these blocks as possible, even if they get cut off. Another option would be if we have a regular block fill, it's going to only allow full blocks, right? So if we go ahead and say that we want a 120 inches between these, that's probably a little small, but that's okay. We can click Insert Install Area. Now we make the reference for the panel orientation here. And you can see wherever I start this, it's going to try and fit those in. Now it only fit 4 blocks here because it would have partial blocks in the other areas. So if I go ahead and do a maximum fill and I do the same thing, I can go ahead and give it the starting point and it would build it from here. But before I do that, I'm also going to add an equipment pad. And now we have to be careful because we're in inches here. So we're going to do 10 by 10 feet, top right, mirrored. And we'll go ahead and insert that install area. And you can see it goes over the entire property here. So, and if I zoom in, I have my little equipment pad, I have my roads, and this is set up nicely. Then now when I click Make Layout, you'll notice I didn't have to click within that because I've already defined my 180-degree reference, and now all of these panels have populated for me, and they've adhered to this kind of extra set of constraints that I have for them. Now, once I've filled out my site how I like it, I can go to Topography and Reports, and I can start to import some topography. So there's a couple options for us. The layer option is going to be if we have topography that's in CAD for us. So what we need is a 2D representation of the topography in contours. That's zeroed out completely on the axis. What we do is we point it to the minor and major contour layers, and we add those in, and then it will run the math off of that 2D contour VAB. Alternatively, what we'll do today is a Google Elevation Service import. So it's a one-click import that goes ahead and grabs the publicly available data for this area and drops it in. And what we'll see is all these dots. But if we go ahead and look at this on its side, we'll see that those dots are actually a 3-dimensional point cloud of the site. So you can see we have some areas that are raised here that we can design around as needed. And then once we have all of this entered, we can go ahead and put in our max minimum pier heights and our max slopes. So this will depend on your racking manufacturer, but I'll put in just some quick demo data here, and then we can run our pier analysis. And what this is going to do is run, it's going to calculate every single pier for us against these constraints we gave it. So it's a little bit more in-depth than a slope analysis that's just going to give us, the slope between 2 points based on some sort of distance. Here we're actually calculating it based off the mechanical layout of the structure design we created versus these inputs. And you can see we have some red areas here. So, these are, when we flipped it on its side, those areas that were a little bit mountainous. So we can see that that's falling outside of our constraints. Here we can also run a pier schedule, which will take this and get the data into an Excel format for us. So we can go ahead and open this up, and we can see that it's going to give us all of our data in that more raw format version. From here, we can also go ahead and export this to a bill of material. Again, this is going to open up in an Excel format. There we go. So you can see it's showing us interior, exterior, different bill of material and what's in spec and out of spec. And then we're also able to export this to Google Earth KML. And there we go. And we'll call this just a sandwich. Not sure where I save here. Ports. And open that. And you can see this is going to go ahead and give us basically every layer we have. So if we wanted to rename the project, we can, and then we can go ahead and we can turn off some of the layers if we don't want to see them. And we have that nice three-dimensional representation. You can see there's those two areas that we saw that were in the red as we could imagine, where the terrain gets a little mountainous there. And then finally, we have a PVCAD export. So if we're able to click PVCAD here, what it will do is it will give us an export in a zip file. Unfortunately, PVCAD isn't a single file import, so that zip file contains a folder directory that replicates the locally installed PVCAD data directory. So what you have to do is just take the export file contents and get it into their corresponding files for PVCAD. And from there, you can go ahead and do your shading scene analysis. Alternatively, there is a quick energy that's available as well. But let me just quickly show you what this looks like here. So here we would navigate to our PVCAD data directory and get these drawings and whatnot right into there. Alternatively, we can also look at the quick energy simulation here, which is going to be not as particular as a PVCAD report, but will give us a monthly report of our energy. And there we have a summary, and we have our monthly and hourly tabs here, which give us the raw output of that simulation. And that's the basic project flow of a project in PVCAD Mega. Make sure to email us if you have any questions at support@pvcomplete.com. Thank you.